Hello students, in our last lecture we studied about refraction of light. Now in our today's lecture we are going to study about topic number 9.4, total internal reflection. Now students, this phenomena can be understood by this figure. Suppose a source, a small bulb, is kept at this point A, and we know that from this source the light will emerge in all the direction. So bulb emits light in all the direction, but we are going to consider the rays on the right hand side of this vertical line. Now students, here this medium 1 is more denser than this medium 2. In short, we can say that this second medium is a rarer medium, suppose it is air, and this first medium is a denser medium, let it is a water. So we can say that a small bulb is kept at the base of the tank filled with water. Now let us consider a ray from point A normal to the line separating two medium. This is the line separating two medium. So this ray is incident to the line separating two medium. So this is the normal at the line separating two medium. So incident ray makes angle 0 with the normal, and so angle of refraction will be also 0. So this ray will emerge out without any deviation. Then consider a second ray which incident at this point O1. So it makes an angle with the normal. This is the normal line. An angle made by incident ray is I. It is shown here. And we know that when a ray travels from a denser medium to a rarer medium, when it emerges out, it is deviated by angle of refraction denoted by small r. And this angle will be larger than the angle of incident I. Angle R will be greater than angle I, because from denser medium to rarer medium. Students, you can see here, this is an incident ray. Most of the part will be refracted in this direction, but some of the part gets also reflected, because at the line separating two medium, these two phenomena takes place, refraction as well as reflection, but most of the rays are refracted towards B. Now once again, if we consider this ray from A, it incident at point O2. Now you see, in earlier condition this angle was small, angle I was small. Now here this I dash is little larger than this I, so angle of incident increased from the earlier case, and so you can see the angle of refraction, that is R dash, is also larger than the earlier case. This is the normal. So when the incident angle increases, angle of refraction also increases. Now next ray, once again the angle of incident increased, you can see now for this ray, the angle of incident still greater than the earlier one. So now at this angle, it was found that the refracted ray is parallel to the line separating two medium. And so with normal, this refracted ray makes an angle 90. So for this incident angle, when the refracted ray makes an angle 90 degree, that incident angle is called a critical angle. It is denoted by IC. So when the angle made is critical angle with the normal, then the angle of refraction will be 90. Now students, what happens? Still, if we take a ray which makes an angle greater than the critical angle, you can see this is a critical angle, and now this incident ray makes this angle which is greater than this critical angle. So now in that case, the refraction will not take place. That means this ray which is incident at point 04 will not refract. That means it will not move in this next medium, that is in air. It will be reflected back in the same medium. So this is nothing but it is total internal reflection. When it happens? When the angle made by the incident ray with the normal is greater than the critical angle. In that case, the ray will not emerge out. That means it will not move in the second medium. It will be totally reflected back. So this is about the total internal reflection. Students, I hope you understood this. Always remember one thing, that total internal reflection will take place only when the ray travels from denser medium to rarer medium. Total internal reflection cannot take place for a ray traveling from rarer medium to denser medium. Now, if we apply the Snell's law at the critical angle, then we will get this equation. Students, you all know about the Snell's law. So if we apply the Snell's law at this point O3, then we know that according to Snell's law, this medium is N1. This medium is N1 and this medium is N2. So when we apply Snell's law, we used to write N1 sine incident angle is IC here, because at this point is equal to, what is angle of refraction? It is 90. So it is N2 sine 90, because angle of refraction is 90. Now sine 90 is equal to 1, and so on right hand side only remained is N2. So now if we write sine IC, then this N1 can be brought towards the right hand side. So we can say that sine IC will be N2 upon N1, and N2 upon N1 can be written as N21. So according to Snell's law, or applying Snell's law, we will get sine IC is equal to N21. Now students, in this table, the refractive indices of different mediums or the substances were given, as well as their critical angle are also given. You can see for water the refractive index is 1.33 and for it the critical angle is 48.75. Then crown glass refractive index is more than that of water, and so critical angle decreased. Dense flint glass, still critical angle is decreased, because refractive index increases, critical angle will decrease. And for diamond the refractive index is highest, 2.42, and its critical angle is lowest, and this is the reason why the diamond glitters. Now the demonstration for total internal reflection. Here some demonstration, that is experiments, are shown. You can see here in a glass beaker a water is taken and a ray is incident from the water, and so you can see some part get refracted and some part get reflected. But in next figure you can see the angle of incident was increased than the earlier. In earlier case, that is in figure A, the angle of incident was this, because this is the normal. So here you can see, now if I draw this normal, then now angle of incident is greater, and it is greater than the critical angle. So in that case you can see the ray of light does not refract, it gets reflected from the line separating two medium. So we can say that this angle of incident must be greater than the critical angle. Now students, here you can see a test tube is shown and a ray of light is entered in a test tube filled with water. So what happens when the ray of light is moving in the water, and then when it strikes this surface of glass, this is the surface of glass, and we know that this glass is having more density than the water. But here we know that after glass this is air medium, here it is air medium, and so when this ray was traveling in the water, here the medium inside is denser and outside is rarer. So what happens, as here at the line separating two medium, this angle made by incident ray is greater than the critical angle, and so this ray will not move in this air, it will not emerge out, means refraction will not take place. What will happen, this ray will reflected in the same medium. Once again it strikes here, once again this is the normal, so this is the incident angle, again it is greater than the critical angle, so this ray will be reflected in the same medium. In that way the ray will proceed. Students, this concept is used in the optical fibers. Now about total internal reflection in nature and its technological applications. Students, Here an example of mirage is given. Now students, in normal condition, that is when the temperature of air is uniform, in that case what happens, a person can observe this tree because the rays coming from the tree do not get any refraction in the air medium. But what happens during summer time? We know that in summer the ground or the surface gets heated due to sun rays, and when the surface or the ground gets heated, the air which is in contact with the surface, it also gets heated. So in that case what happens, here near the ground there is a hot air, and as we move in the upward direction the air becomes cooler and cooler. So when the air is hot it is less denser, and if the air is cold it is more denser. And so we can say that near the ground or near the surface this medium is rarer medium, and this medium above is denser, and this density gradually increases as we move in the upward direction. So gradually density increases. So in that case when the ray is coming from the tree, actually this ray is not emitted by the tree, it is the sunlight only. The sunlight falls on this tree and that ray is reflected, and that comes to the eyes of an observer, and so this observer can see the tree. So what happens, when this ray is coming from the tree, what happens, gradually when it moves in the downward direction, what happens, one ray is directly coming, and so a person can observe this tree here, but the other ray which is moving in the downward direction, because we know that from any object many rays are coming, so here we can say that due to this ray a person can see this tree directly, actual image. But what happens for the ray which is moving in the downward direction? So that ray is moving from the denser medium to rarer medium, because we know that upper air is colder, so its density is more, and lower air which is hot, its density is less. So gradually the refraction will take place because the density of medium changes, and so this ray will bend away from the normal, because from denser to rarer what will happen, it will bend away from the normal. So this process will take gradually, and so you will find there is a curvature. Then at one point what will happen, there will be a reflection, total internal reflection we can say. So ray will completely bend, and then once again when it is moving in the upward direction, what happens, it is moving from the rarer medium to denser medium. So this curvature will go on in this way, and this ray which was moving in the downward direction, actually in this direction it was moving, but due to difference in the densities of the medium, what happens, it gradually bends and reaches the eyes of the observer. And so when we draw the tangent from this point of the observation to this ray, it moves in this direction, this is the tangent, and this is the actual object, so this is normal we can say. And so what happens, this person will observe the image of this object, and so this is due to total internal reflection. So an image can be observed. Students, you might have observed during summer when you are moving in a car that at a far away distance you find water surface. That means some water is split on the road. That type of illusion is observed on the road during summer, because in summer the roads get heated, and so the air above the road, it is hot, and due to that what happens, we feel that there is some water split on the surface. And you can also observe the image of any building in front of you in the surface of that road. So this is due to total internal reflection. Students, one more effect called a looming effect. In looming effect, what happens, in a sea, during summer in a sea, you will find a boat or a steamer inside the sea above the surface of the water. You find that that boat or a steamer is not floating on the surface of water, it is above the surface of the water, just in a air. So that effect is also due to this total internal reflection. That is called a looming effect. Now here different types of prisms are shown, and the total internal reflection in this cases in different types of prism is shown. In this first, you can see this is an object AB, rays coming from the object, that is from the top and the bottom. Actually from all the places the rays are coming, but to form the image we just take any one point. Here 2 points are taken. So these two rays are coming, and here it incident at this surface, but the ray is incident normally to the surface, so there is no deviation, so it will move in a straight path. But when it gets incident at this surface, when it incident at this surface, at this point we can draw this normal line. Normal is always perpendicular to the line separating two medium. So as this angle made is greater than the critical angle, see here this angle is 45, and it is greater than the critical angle for this material of glass of which this prism is made up of. So what happened, this ray will not move in the second medium, that is it will not emerge out, it will simply reflected back in this direction, making an angle 90 with the incident ray. You can see this ray strikes here and it is moving in this direction. Once again here it strikes at this surface separating two medium. Here there is air and here it is glass. So what happens, this ray will once again move normally, and so angle made by incident ray and emergent ray is 90. Similarly you can show for this point A also, and so image is formed in this way. Actual object is vertical and image is towards the left side. In this way it becomes horizontal. So here 90-degree deviation of the ray took place. Now here in this case you can see this is an object. Here the ray incident from point B strikes here but here the angle made with this normal will be greater than the critical angle, so it gets reflected because of total internal reflection. Once again it strikes here, but this is the normal. Once again with normal this angle made is greater than the critical angle, so it will not emerge out in this direction. It will be reflected and then it will move here. So image of this point B will be formed here. Similarly, for ray coming from point A, this type of total internal reflection will take place and its image is formed here. So you can see here the object is in the upward direction, vertically upward direction, but the image is vertically downward, that is inverted image is observed. If a person is observing from here, then he will observe the image which is inverted. Students, in first case you can see one time total internal reflection take place at this point, but here in this case you can see two times, one time here, first time here, and second time here at this point. This is the first time the total internal reflection took place, and here it is second time. And so overall 90 plus 90, we can say the angle made by incident ray and the emergent ray, this is the incident ray and this is the emergent ray, it makes an angle of 180 degree. So 180 degree deviation took place. Now in this prism you can see the object is shown here. From this point A, ray is incident at this point, it gets refracted, and then when it strikes here, it gets total internal reflection, because this medium is glass medium. This is suppose N1, it is made up of glass, so it is denser, and this N2 is a rarer medium, that is air. So here what happens, when ray strikes at this point, this is normal and this angle made here is greater than the critical angle, so the ray suffers total internal reflection. Then it strikes here, and now when it strikes here, you can see at this point this is normal. So in that case, with normal here, the angle made is less than critical angle, so now total internal reflection does not take place, the ray will emerge out, and so image of point B is formed here. Similarly for point A, this type of refraction here, then here total internal reflection, and then once again here it is refraction and image is formed here. So here what happens, this object is erect, straight, vertical, but the image formed is inverted. Both are in same line, but the image is inverted. So suppose if the person is standing here and if he is observing the object which is here, then he will observe that object inverted. Now about optical fibers. Students, generally we know that for data transfer the cables are used. Even for internet connection we know that there is a transfer of data through wires. So generally the cables consisting of metallic wires are used. But what happens in that, due to that electric current, the data transfers in the form of electric current. So in that case, sometimes data they get leakage many times because of radiations, electromagnetic radiations coming out from that current carrying wire. So leakage is possible in such type of cables even at a large distance. Due to resistance in the wire, energy get lost, lots of energy is wasted. But if optical fiber is used, then the loss of energy is also minimum in this optical fiber, as well as the leakage of data will not take place, as well as large amount of data can be transferred from one place to another place in few seconds. Students, here an optical fiber is shown. Here this core region that is inside it, it is not hollow, it is made up of a glass or a quartz. It is a glass fiber or a quartz which is little flexible so that this wire can be bent. And here this surface is a cladding, means the surface of this wire is having refractive index less than this core region, that is that of fiberglass or quartz. So here the core region is made up of fiberglass or quartz, and this cladding is done by some material which is having a less or a low refractive index than this core region. So now what happens when the light enters once in this optical fiber, it will incident at the surface separating two medium. It suffers total internal reflection, and in this way light will travel by multiple total internal reflection, and it will emerge out from the next end. And due to total internal reflection, there is no leakage of this light. So students, this is the concept of optical fiber, and here it is given that for 1 kilometer of length of this optical fiber, only 5% energy is supposed to be lost. 95% of the energy is obtained at the next end. Rest of the things you can read in the textbook, and you can get more information from it. Students, also you might have seen some lamps using optical fibers. A cylinder is there, a small bulb is placed here, and it is a base, that is stand, and here there are optical fibers. So what happens when this light travels in the upward direction, it emerges out from these optical fibers, but only these points is found to be glowing. The whole optical fiber is transparent, but still the light will not emerge from its surface. It will emerge from these ends only, that is tips of this wire, and you will find like a glowing tree or glowing plant. So this type of lamps are also available, decorative lamps.